This is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In this video, we will see about the application to the solution of a statically indeterminate system. It's complementary energy application or application of complementary energy for solving the statically indeterminate system. Okay, so this will be our lecture topic. Now, the question is the simply supported beam ABC. So ABC is the simply supported beam shown in figure is stiffened by an arrangement of pin joint bars. So now this bar, that means these loads are acting, that is stiffened by a pin joint bars capable of sustaining axial load only. So this bar can sustain only the axial load. If the cross section area of the beam is AB, actually this should be that A subscript B here, this one AB, and that of the bar is A, right? And these bars having cross sectional area A, it's given here, right? Calculate the forces in the member of the framework, assuming that displacements are caused by bending and direct force action only. So means in each member like A, E, E, B, E, R, we have to find what the forces in each member, and that displacement, because of the displacement is what? Because of the bending and direct forces only. So whatever the other things will act, that we have to ignore. So now just see. Again, for this first, we had seen this type of problem before this also, where like this figure was there. Here some 40,000 force was acting here. 1 lakh was there force, right? Then what in that what we did, we found first the reaction at this point. So in the same way, like whatever the problem is there, the same way we have to solve the same here also. This problem already we had seen, I think in video 4 or video 5, you can find the solution of this problem, right? So now the same way but for indeterminate structure. Okay, so what we will do, we will find first force. Okay, so now let's see how much it is. Just see here, it's a given at L by 4th length, that is this is total L. So at L by 4 length, P force is acting, and B distances, that means A to B is L by 2 and B to C is L by 2. This is given, and here this R is acting in this direction. So this is given. Now with that we have to find. So we will find first RC and RA. So after finding RC and RA, we will get 3 by 4P and 1 by 4P. So RA as 3 by 4P and RC as 1 by 4P. So let's see how. The same way, what we will do, first sum of all the horizontal forces must be equals to vertical forces. So that one. So here for this point, what is there? Let's, here reaction is acting as RA and here RC. So with this, these two are acting upward and this force is acting downward. So means what? RA plus RC will be equals to what? P, because these two are acting downward, upward, and this is acting downward. So opposite means RA plus RC equals to P. So this is first equation. Now for finding what we require, two unknown is there, RA and RC. So two equation is required. So first we got by the force. Second we will use the moment one. Right. So take from any point. Let's take RA at the reference. So means from RA we are finding. So RA into moment we are taking. So distance from RA to RA is 0 plus this one. P into L by 4. P into L by 4 is the distance from here to this one. And then plus what? This will be the RC into L. So now just see here, if this will create clockwise and this will create anti-clockwise. So that's why minus here what? That RC into L. RC into L, and that must be equals to 0 for equilibrium. So from here RC will be equals to what? We can write here this is 0. So RC L or minus is equals to PL by 4 from here. This, take this to the side. So RC L equals to PL by 4. So from here L will get cancelled. RC equals to P by 4. So see, RC equals to P by 4 we got. Now substitute this value here. right? So RA plus for RC I'm writing P by 4. P by 4 equals to P. Take this side. So RA equals to P minus P by 4. That will give you what? RA as 3 by 4 P or 3P by 4. So now we have RA and RC. Now what we will do, same energy method means we have to find by the joint method forces acting on each member, right? So I am just recalling again that same concept here. So let's see. So what we observed that if the beam were only capable of supporting direct loads, then the structure would be a relatively simple, statically determinate pin joint framework. So here, what? It's a supporting direct loads only, right? Since the beam resists bending moment, we are ignoring shear effects. That's why it's clearly mentioned here. What? Because of the bending and direct. So there is no need to consider the shear force or shear stress, right? The system is statically indeterminate with a single redundancy. So in this case, redundancy is single. The bending moment at any section of the beam, right, that will be given. So the total complementary energy of the framework is given with the notation previously developed by. So already we had seen this one, right? So this is for the moment. This is for the fixed force or that Fi, and this is the load acting on that one. So here load is acting what? Pi. So this is the complementary equation. So now for the moment we have to again consider that in previous problem also we had seen A to B, B to C, like that we found, right? So same way here again from A, B, C, that A to B, B to C, or whatever is given according to that, that means from A to C we have to take everything including B also. So now for this it's easier. For here lambda we can put again that lambda value whatever is there. The thing is again here we have to find d theta dm. Okay, so now just see how we will find, right? If we suppose that the tensile load in the member ED is R, so now here we are assuming in this ED is the tensile force, that is R, right? For C to have a stationary value, for C that complementary having a stationary value, what? So now just see here. So first AB, BC and CD. See the figure. It's given. AB is L by 2, BC is L by 2. Right? So from here to here, this length is what? L by 2. And this angle is given 60 degree. Means what? It's obvious this also will be 60, 60. Right? So that's why that is equilateral triangle, and hence, so here this is 60, this also will be 60, 60. So equilateral means whatever this length will be there, same will be here also, here also. So this length is what? L by 2. Therefore, L by 2, L by 2, equilateral triangle. Right? So we all are a equilateral triangle. This also 60, 60, 60, 60, everything. So from this, it's a 60. So means all will have the same length, means L by 2, L by 2. So now in table, first column, L by 2 is ready. Now area, because what we have to find in value of lambda, we have to put that time L and A is required, right? So now we are finding area, cross section area. Now let's see, it's given here for this A to B, cross section area is AB, BC cross section area AB. For remaining all, AE cross section area A, EB cross section area A, ED cross section area A, BD cross section area A, DC cross section area A. So now just substitute it. Okay. Now the main thing is this, we have to find the force. Again by the same method we will find here, this is what? Force. And you see here it's given tension taken as positive. So if compression will be there, then we have to take negative. If tension is there, then we can write as positive. Now we have to find what? For member AB, BC, CD, D, like that. So let's see what will be the force in member AB, right? So now just see, right, in this one, this we know, right? Here 3 forces are acting, means now I'm taking at point A, same by joint method, at point A. So what we have, this is A, B, then here it's acting how much, 3 by 4P, and this is here, right? And in this it's given R, right? This is there. So now we will take, or we will resolve this one in these 2 directions. Okay, and after that just see here, this is what, this is that just we assumed here. If we suppose that the tensile load in the member ED, so in ED we assumed that this is the tensile load. What load is there? R, right? Length is getting divided, L by 2, right? So for each forces, wherever the compression is there, it will be minus R by 2. So in A, B, L by 2, cross section area is AB, and here the compression will be, that load will be, again you can find by the joint method, right? Sum of all the vertical forces equals to 0, sum of all the horizontal forces must be equal to 0. Like that you can again find all the forces for each member. Once you have the force, what is the next? Differentiate. We just see here, R is force, we assume that fixed force, we assume this time R. So means you have to differentiate with respect to R. So first case, dou F by dou R. So dou F by dou R, R is variable here, so R will get cancelled, means minus 1 by 2. In this case again, minus 1 by 2. Here R, dou F by dou R means 1. R, so 1. Minus R, minus 1. Minus R, minus 1. R, 1. Right? So now we have this dou F by dou R. Next, what is required? F by A into dou F by dou R. Or you can just take another column here, right? Or you can find first what? F by A also. Or simply just see F, you have A, you have. Okay, so I am showing how to find this one. So first, what is required? F by A by AB. So for AB, I am finding, right? So AB will be what? F by A. F is how much? Minus R by 2, okay, by F by A. So by AB into dou F by dou R into minus 1 by 2. Minus minus become plus. So R by 4AB. Okay, so R by 4AB we got. Similarly, for this, if you will put again, what will be there? Same again, because all the values are same, right? A also same. Now for this one, so for I am finding for CD. For CD will be what? R. Okay, that force is what? How much? R by A into dou F by dou R. Dou F by dou R is how much? 1. So 1 means for CD it's R by A. So see here, CD R by A. So for like that only we can find all the values here in this table, F by A into dou F by dou R. So now this table is ready. Next, what is there? Now this time we have to differentiate with respect to C. So which equation? That this equation. So let's see, differentiating with respect to C. Sorry, with respect to F. So after this, just here. Okay, with respect to, sorry, this time we assumed with respect to R. So we will differentiate with respect to R. Okay, so now here only I am integrating, right? So just see, don't get confused with again P. Earlier we got the delta value, that with respect to P we differentiated. So that's why our fixed force was P. But here this time fixed force is R. That P is acting load. So after differentiating this, what we will get? Dou C by dou P, sorry, dou R is equals to this A, B, C. This will get cancelled, differentiation. Now this we can write d theta into dm by dr, or dou m by dou r, plus this will be what? I equals to 1 to k. This will get cancelled. Sorry, this will get cancelled. Then what we have? Lambda I into dou fi by dou r. This we found, right? lambda is. Lambda is what? Already we had seen FL by AE. FL by AE. So FI, LI by AI. EI is our lambda I. So next step what we will do? We will substitute after differentiating. So this will be the differentiation. Just equate to 0. So here after differentiation we will get this one equate to 0 for equilibrium. That must be equals to 0. At this point we assume the appropriate load displacement relationship, right? This is again we shall take the system to be linear so that equation becomes now for linear equation we are taking. So for linear equation only lambda value was what? Fi Li by Ai into E. And already we in previous video also we had seen how m that is d theta is m by Ei into dz. Or let's see here for any curve like theta equals to L by R is there, right? So this can be write L into 1 by R, where 1 by R is the radius of curvature, right? So now L was what? dz. 1 by R, that is the radius of curvature, which is equals to what? Ei by m. So radius of curvature is equals to 1 Ei by m. So 1 by R, if R is E, I by m is R. So once 1 by R will be what? So this will give you dz into m by Ei, right? So from here only we got d theta as m by Ei into dz. Okay, so now just substitute it. That replace theta, dou m by dou r. Okay, next. So again we have to find dou m by dou r, that is left. So just see it first. Now Fi Li by Ai E. So in that Fi Ai Li is known. E is also constant. So in terms of E also we can give. If value of E is given, then you have to substitute that value. Dou F I by dou R already we found in the table, and how to find that also I explained. So now the two terms in above equation may be evaluated separately. So you can separately this evaluate this separately and then later add and equate to 0, or else you can solve this simultaneously, but that simultaneously it becomes bigger. So better just to mention like part A, B. Okay, right here solving part A, right? After finishing that solving part B, and just give some equation name to this one, and then from solving this and this substituting in this equation equal to 0. So let's see how to find this one. Okay, so let's see here. Bearing in mind that only the beam ABC contributes to the first term while the complete structure contributes to the second. So in this case already we had seen that ABC was there, right? So ABC only this length will be there. So whatever the value of this will be there, that you have to take. But in this case all the members will be there. That's why Fi is there. Here there is no Mi, right? If Mi is there means for all the members also you have to consider, but there is no Mi. So because of the moment is moment is because of that rod or beam ABC only. Evaluating the summation term by a tabular process, we have table, right? Already we found. Now just putting the values. So what is required? Just see here. For first second part we are evaluating. So second part what is required? Fi Li by Aie, okay, into dou F by dou R. Okay, so now this is required. So just see it's a sum of all. So it's what we can do first. There we found Fi by Ai, and then this is required. So only E will be what? Common to all. So from this table, if you will add this one, then what you will get? Just see here, because this term Li is not multiplied. Why? Li is common to all. So we can take Li by E as constant, right? So what is required? That's why here in this term Li is not. Otherwise, if Li is different, then here one more term will be there, or one more column. There you have to multiply each whatever the length will be there in that case. But here we got length as same for all. So that's why need not to multiply. Just take from this equation what? Li by E as common. Okay, so Li is what? L by 2. So now after adding all the values, right, just see here. I'm adding here. So what we will get? R by 4A. So this will be R by 4AB, R by 4AB. So this way I can write R by 4AB plus R by 4AB. Right. So this denominator same. So this will give you what? 2R by 4AB. This 2 get cancel. So R by 2AB. So these two we got R by 2AB. Plus how many R's are there? 1, 2, 3, 4, 5. Right. So simply we can write directly 5R by A. So after adding what we will get? After adding these two, so 5 or this one, R by 2AB plus 5R by A. So sum of this will be there into what? L sum of all, that Li by E. Okay, so what is L here? L by 2, right? So that here. Okay, so see here what we got there, 2 by EB, R by 2AB, 5R by 2AB, right? So now multiply and divide by 2, or just multiply and divide by 2. So after multiplying and dividing by 2, what we will get? So this is L into L by 2E I am writing here, okay, and multiplying 2 with each term. So 2R by AB plus 10R by A. Okay, 2 cancel, take R common. So after taking R common, what happened? It becomes RL by 2E. Okay, and this will be L by 2. So this becomes 4. So RL by 2, now this removed, 4, and this will be R common. So 1 by AB plus 10 by A. So this will be the sum of that all. Let's see here. So this is the second term of this equation. So now we found this equation, that we solved this one. Now we have to find this one. Means again, first what we required? We required M, that moment equation. Once we will have the moment equation, we will differentiate with respect to dr, and then we will integrate it. So finally we will get the answer. So for finding first moment, let's see how to find. Okay. So now the bending moment at any section of the beam between A and F. So see the figure, right? First from A to F, then F to B, B to C, like that we have to find. So first A to F. Okay, so A to F. So M will be what? 3 by 4 P, that already we got that side, into Z. This is moment, that reaction A, and this is minus root 3 by 2 R Z. Now how minus 3 root 2, right? R, that will be the force into Z. Okay, so let's see here. M. So for M, here is the 60. So once you will take the resolved part of this one, what happens? This will be downward, this will be upward. So this is sine 60, that is root 3 by 2 R. Hence we got this as root 3 by 2 R, and Z is the distance. So now we have the moment equation. Okay, once we have the moment equation, next step is what? Dou M by dou R we have to find. Remember R, because here R is the frictious force. Earlier also I forced that don't get confused with the differentiate with P, because P is not here the frictious force. P is the actual force acting, that is given in the question. So after differentiating, this term will be what? This is constant, so 0. After differentiating this with respect to R, what we will get? Minus root 3 by 2 into Z. So here minus root 3 by 2 into Z. Next, now between F and B we have to find. So between F and B, let's see the image. Now from here to here we have to find. So this time what will be the Z? L minus Z. Wherever we will take, if suppose this length is L, so for A to B, that will be L minus Z. Okay, so P by 4 from this side, that reaction, right, into L minus Z, minus same this minus root 3 by 2 R into Z. So now we have what? So this time, because here is there, so from here we are finding, so this distance into this one. So if this is Z, so this will be what? L minus Z. So 1 by 4 into L minus Z, because now this also we have to consider in this we are taking, right? And then for this one, okay, and minus P by 4 L minus Z, and for this again R minus root 3 by 2 R into Z. So now after differentiating, what happened? Again this term will be 0. This will give again what? Minus root 3 by 2 Z. So now we have what? Dou M by dou R between F and Z. Now next is what? B to C. So for that B to C, we have to find again the same moment equation. Once we have the moment equation, we will differentiate, we will get dou M by dou R. So now between B and C. So this will be again same between C, L minus Z, and this will be this time 3 by 2 R L minus Z. Now just see the figure, because now from here to here, so this time here is the Z. So what distance will be here? L minus Z, right? So that for that Z we have to find. Okay, so now minus 3 by root 2 into L minus Z, that is the final moment equation. Next step, differentiate with respect to R. So again this term will be what? 0. Okay, so only what here this time, just see, you will get this one, only this R will get removed. So minus 3 by 2 into L minus Z. So dou M by dou R. Now what we have to find? This value. So now just see, in 3 parts we found, that is from where to where? A to F, F to B, and B to C. So whatever the length is there, the same length we have to take. So A to B, see the figure, A to B, what is the length? A to B is L, from here to here is L by 4. So from here to here will be what? L by 4 to L by 2. And this is L by 2 to L. So these limits we have to take while integrating. Means again this we will reduce into 3 separate integration with limit 0 to L by 4 for first, that is from A to F. In between F to B, we will take limit L by 4 to L, and L by 2, and from B to C we will take L by 2 to L. Okay, so now just see here, 1 by EI is constant, so taken out common. So this is between 0 to L by 4. What we, from which one we got? That is for A to B, A to F, this one, right? This is there, that is M by EI. So after substituting the value of M, this is M, EI is constant, and dou M by dou Z is here. Okay, so after M, dou Z. Now here just multiply, and so first just see here this part. Now from L by 4 to L by 2, this we got as moment, this we got as what? Dou M by dou R. Okay, similarly for third one, L by 2 to L, this is the moment equation that we got, here it's there, right? And this is the value of dou M by dou R. Okay, so now after substituting we will get this value. Now see, the very big equation is there. So while integrating, take care of that one, or else you can integrate 1 by 1 by putting proper bracket. Okay, you can just give a name as I1 for this one, I2, this one, I3. But just see, once you will multiply and this one simplify, then that becomes easier. Okay, so let's expand this one and see what we are getting. Okay, so first what we will do, we will multiply this to whole term. So first minus also parallelly multiplying. So minus 3 by 4 into root 3 by 2. So this we can write as minus 3 root 3 by 8 pz square dz. Okay, and then minus become plus. So plus root 3 into root 3, 3. So 3 by 4 into r z square dz. Okay, so now we have to integrate from 0 to L by 4. So this we can 0 to L by 4. Separately we can integrate 0 to L by 4. So now this will be common free. So z square dz integration is z cube by 3. So minus 3 root 3 by 8. Okay, p common. Now integration of z square dz is z cube by 3. Okay, limit 0 to L by 4. Then plus again 3 by 4 are common. So 3 by 4 are common. Now integration of z square is z cube by 3. From where to where? 0 to L by 4. Okay. Now here you can substitute the values. Okay. So now just see, this value is common. So for solving this and putting, you can take this itself common, right? Because r square z is coming. So take z cube by 3 whole limit common first, and then later put the limit value. Or you can simplify here also. So just I'm writing minus 3 root 3 by 8 p. Now the CR, z is L by 4. So L by 4 whole cube by 3 for this one, plus 3 by 4 r, this one z cube again same, L by 4 whole cube divided by 3. Okay. Now after expanding, that is taking, this becomes L cube by 64, right, into 3. Similarly here also this will be. So after simplifying this, what we will get? Just you have to simplify this one. After simplifying, you will get this value, right? So do m by do m by do z will be this one, the first for this. Now what we have? Okay, so this was substituting equation 4 and 5 in equation 3. So this is your 5 and this is 4, right? And this is third. Okay, this is second, and in previous first equation was there. So now you have all the values. So this is for what? This part we solved. Similarly, you have to solve for this part also. So after solving for this part, solve for this part also, then add all the values. After adding all the values, what you will get? This value total. So once you will add all the 3, you will get this value. Now what you have to do? You have to, or just see, let's solve for this one also, some steps later you can just find. So now what we have? L by 4 to L by 2. Now this one I'm multiplying with here. So minus 3 by 2 to this one. So minus, it becomes minus 3 by 2. Okay. P by 4 into L minus Z into Z. So, sorry, Z into Z. First term we multiplied here with this one. Now if multiply minus 3, so it becomes plus 3 by 2. Okay, plus 3 by 2 rz square. So plus L by 4 to L by 2. This is 3 by 4 rz square. Now again this further you can simplify and you can integrate it, or itself first expand this one, right, and then just integrate it. After integrating, what you have to do? You have to substitute the limit with L by 4 to L by 2. Or let's see, just I am doing some. So this is minus 3 by 8 p is common. Okay, minus 3 by 8 p is common. So now this will be Lz minus z square, and dz also will be there. Right here, dz with each term. So Lz minus z square dz, right? And for this one, plus L by 4 to L by 2. Simply this will be 3 by 4 r common. Here z square dz. So this term is here. Okay. Now limit is L by 4 to L by 2. So minus 3 by 8 p Right, now I'm integrating. So Lz integration L z square by 2 minus zq by 3. Limit will be what? L by 4 to L by 3 plus similarly here 3 by 4 r integration is zq by 3 L by 4 to L by 2. Now just put limit here. Okay, so what we will get? Minus 3 by 8 p, use proper bracket. L, z is what? Now L by 3. So L into L by 3. So L by 3 whole square. Because z square is there. L by 3 whole square divided by 2 minus this one zq. So L by 4 to L by 2, not L by 3, L by 2. So this is L by 2 power 3 by 3. So this term minus, you have to put this also. Okay, so this, take this common. So now L into z square. So L by 4 whole square by 2 minus L by 4 whole cube by 2. So now after simplifying this, okay, whatever you will get the value, that will be for the second one. In similar way, you have to do for the third also. Third, just first multiply, right? That means just expand this equation, then integrate it and put the limit L by 2 to L. So make sure that lower limit and upper limit should be there. So while taking upper limit minus lower limit, don't forget to put that one. So after finding this value also, similar way you can find this value also. Once you will substitute this value, what after this 3 you have to add, because this is the total value. So after solving this one and this one, add all the 3, because just see here plus sign is there, right? So whatever the value you just add, and after adding this, what you will get? That this value you will get. So once you will add all the 3, you will get this value, that is the equation 5. Now what is next? Substitute 4 and 5 means this value and what we got, this value in which equation? Here. So this just simply this and this will get added. So here we will get 2 terms only. So that's why here 2 terms are there. Just see here first what we got here. This RE RL by 4E into 1 by AB plus 10 by A. Sorry. Okay. And then here. So this is our what? Second one after taking LCM. Right. So this is for the Fi part and this is for the moment part, because the CM moment we got here after substituting this plus this is equals to 0. Now what is required? That R. According to the question, what is required? That R. Right. So now you have to simplify, take this denominator part one side, okay, and then simplify it and find the value of R. So just see here R and R in these two is there. Right. You can take common, but for that first you have to expand, or else just take this side, one side, that is R, take R common and then divide by whole. So let's see how you will simplify this one. So what I'm doing, I'm taking this to that side. So, or this to this side. So this will be positive. Okay. So I'm keeping this and taking this to this side. So R LQ by 16 EI minus R L by 4 E. Okay. So see here, with this item will be there 4 E into A plus 10 A B divided by A B substitute into A. Right. That is equals to, this will go that side. So 11 root 3 PLQ by 768 EI. Right. Now we can take R common from here. So after taking R common, what we will get? LQ by 16 EI minus L by 4E, okay, into A plus 10 AB by AB into A. that is equals to what? 11 root 3 PLQ by 768 EI. So now for this what? This whole thing will get divided here. So simply R will be equals to, here I am writing, R is equals to what? This one. That is 11 root 3 PLQ by 768 EI whole divided by this term. Right? Whole divided by what? LQ by 16 EI minus L by 4E into A plus 10 AB divided by AB into A. Okay. Now take the LCM, simplify. After simplifying, just you have to take the LCM. Right. After simplifying, you will get this value of R. That is value of R. From here, you will get this one. So just after this, only the LCM I need to simplification. That simplification is required. Okay. So now just see, I'm quickly recalling. Okay. First, this is given. So first what we did, we found reaction at A, reaction at C by the general method. After finding that one, what we got? RCS 1 by 4P and RAS 3 by 4A. Next, what is that? Complementary energy equation. That we know this is the complementary energy equation. Right? Here Fi is Fixed force. P is already that given force is there. Here there is no Fixed force, that P lambda. That's why it's a P. Next, what? A, B, C, D, just whatever the members are given, that note. Whatever their length is given, length also that given it's at 60 degree, right? So means it's a equilateral triangle, so length of all the member will be same, which is equals to what? L by 2. So now we have L by 2. Area also is given for the beam A to B and B to C. Yes, AB, and for remaining A. So this is this one. Now by using the joint method, for take each point, sum of vertical forces equals to 0, sum of horizontal forces equals to 0, find the value of F for each member. Right? Next, after finding the value of R, that is F, differentiate with respect to R, because here R is the Fixed force what we applied or what is required. So after dou F by dou F, after differentiating this, what will R will get cancelled, minus 1 by 2, and wherever R is there, that becomes 1. Next, let's see here, because L is constant. Otherwise, if L is not constant in the given question, then here you have to multiply FL also. FL by A you have to find. That is Fi, Li by AI. But for these two only, A is different. For these four, A are same. Right? So now, no need to multiply, just L. We can take directly L by E common. So just multiply this, and this one. That is 4 into 5 divided by 3. This you have to do for this one. Right? So all that is 4 into 5. So minus R by 2 into minus 1 by 2 divided by AB will give you 4RB. Similarly, R into 1 divided by A will give you RA. Right? So now we have this one. So then you have to find some sigma of this one. Sigma of F by A into dou F by dou R. So just add this one. Already I showed you how to add. These two will be same and this one. Right? So once you have added this one, you will get this one. What is that? R. Okay. After taking R common, L by 2 was given. That length 1 by LE. That PL upon E. So L we are taking constant, not multiplied with each term. So now here L by 2E putting, and from there to just common, or just after adding this you will get. Okay, after adding and multiplying by L by 2 with this term, you will get this one. So first part we solved. Now next what we have to do, we have to find the moment for each point, that is from A to F, F to B and B to C. So A to F moment will be this one. Then what is required? 2m by dou R. So they just differentiate with respect to R. You will get this one. Similarly between F to B, this is the moment. Next, dou m by dou R will be, this will get cancelled because P is constant. Here also this will get cancelled, that is 0. Differentiation will be minus 3 by 2R. Similarly here also minus 3 by 2R. So now we have F to B. So next B to C. So B to C moment is this one, right? And after differentiating with respect to R, we will get dou M by dou R in this one. Now the whole equation for finding this one will get divided into three parts. From where to where? According to the figure, 0 to L by 4. Next one, L by 4, that is 0 to L by 4 is for E to F. And then L by 4 to L by 2 is for F C and F B, and L by 2 to L is for B C. So now for finding all these things, just split it into 3 and put the value. So this is M for A to F, this is dou M by dou F A to Z, this is M for F to B, and this is dou M by dou R F to B. This is M for B to C, and this is dou F by dou R B to C. So just substitute the value. Now multiply, that we just open that bracket, and after simplifying, integrate it. Similarly here also multiply and integrate it. Multiply, integrate it. So after multiplying and integrating and substituting the proper limit, whatever is here. For this part 0 to L by 4, for this part L by 4 to L by 2, and for this part L by 2 to L. And after simplifying, what you will get? This value, right? So dou M by dou P value will be this one. So now what is next? We have to just add. So this is our equation number 5. Okay. So now next is what? Just add 4 and 5, or just substitute 4 and 5 in 3. That is equals to 0. So this is 5. This is 4. 5 plus 4 is equals to 0. After solving this, from here you have to find the value of R. I showed you how to find. So finally this will be the value of R. So see, calculation is too long, so each step you have to take care. That means otherwise you won't get this value. And suppose if you are doing by calculator, then also make sure that should be very near, about at least near to decimal. That value should be same. You can use calculator itself, but take up to 3 decimal, whatever the value you are getting, so that the value will be near to the actual answer of this one. Okay. So again, for this question also you can refer a TG Maxon book. Okay. So if you have doubt for finding any like force or anything or any step, you can just comment on the video, or you can contact me. Okay. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.